So this is section, let's see, 7.4. Write down the compound interest.
So for quarterly, it means like a quarter of the year, or?
Yeah, so let me give you the formula first. So that word quarterly, etc., that's going to be what tells you what n is going to be.
All right.
Let's write the formula down. So for compound interest, the future amount A is equal to P times 1 plus R over N to the NT. Let me double check the formula before I get paranoid. Interest. Yeah, there it is. 1 plus R over N to the NT. We defined last time what all that meant. I'm gonna write it one more time, just in case. P is still principal. R is the interest rate. A is the future amount. N is the number of times you compound per year. You compound per year. So quarterly would be 4. Yeah. Time must be in years. Okay, so this first example, we just have to write down what we're given and then calculate whatever they ask. So they may ask for, actually, you know what? Let me give you a couple of formulas. If I solve for P, you can have this formula here. So if they ask for principal and they give you the future amount, use this guy. Negative NT. I don't think they will ask for rate because rate is trapped inside. That would require, oh, we could do square root nonsense, but I doubt it. We'll find out. If we need it, then I'll create it for you. Okay, so example 1, Maria invests $3,000. So that's my principal in an account that pays annual interest of 5%. So let's write down all this stuff here. Example 1, P is 3,000. R is equal to 5%. How much does she have in the account if it's compounded quarterly? That means N is 4. So part A, they give us time equal to 1. Part B, time is 12. Okay, so let me switch back. Okay. So we can't use it as a percentage. We must change this to a decimal. Percent means out of 100. So divide 5 by 100. That gives you this. Or just move the decimal point. Same thing. So she has in the account A, future amount, 3,000 times 1 plus R over N. So that would be 0.05 over 4 to the NT, that'll be 4 times 1. So just punch that into your machine. At this point, you have to have a calculator. So 3,000, 1 plus fraction button would be 0.05 to the 4 times 1. That's something up. Maybe go back to math print. Three thousand 1 plus 0.05 divided by, well, here we can use the fraction button. That's only good if you're in math print. But either way. So that seems reasonable. In 1 year, she made about $52. So this is approximately 3,152.84. So now let's see how long, what happens, or how much money she has in 12 years. So same formula, just change the 4 to a 12. I'm sorry, the 1 to a 12. So I'm gonna just copy that, do it again, and change this top part to 4 times 12. Just to be lazy. So it'll be 5446.06. Usually they'll tell you to round to the nearest cent, or they might say round to the nearest dollar. We're not going to keep all that fractions of a penny. But anyway, so very similar to the last section we did. We're just using a new formula. So they may ask future amount given different scenarios or different amounts of compounding. So that's example 1. Example 2, they're asking you what happens when you compound differently, annually, semi-annually, quarterly, and monthly. So the only thing that's going to change here is going to be the n. Okay, so the n on each of these, right? N is 1 here. It's the worst n I've ever written. N is 2 here for this one. Semi meaning twice a year. Quarterly is 4. So we'll write this on the paper in just a second. Monthly, which is 12 months in a year. So remember, n is how many times you compound in 1 year. Okay, and they're going to, they only want to know what happens, how much money you're going to have in 1 year. So time will be 1. So let's write all that stuff down. Example 2. Principal is $10,000. Rate is 0.04, which is 4%. Time is 1. So part A, they're going to compound annually. Let me switch back. two n's or one, I don't remember. So here n is one. So formula will be 3,000 over, it should be 0.04, not 5. Because it is 4%, so 0.04 divided by the compounding, which is 1, to the 1 times 1. So 3,000 to the 1 plus 0.04 divided by 1. I guess I could use a fraction point instead. It's prettier. 0.04, 1 to the 1 times 1. I know that 1 times 1 is unnecessary, but later we can just copy it and just replace it. So 3120 seems reasonable. It doesn't seem insane. So they have about 3,120. Now, semi-annually,
N would change to 2, so it'd be
yeah,
1 plus 0.04 divided by 2, and then 2 times 1, right? Or 1 times 2.
yeah, exactly. There you go. 1 times 2. So I'll go back in here and just change them all to 2s. Enter 2, 2. So it should go up, right? Compounding more often. That's about $3,121.20. Compound quarterly. And it will be 4, right? So A will be 3,000 times 1 plus 0.04 over 4 to the 1 times 4.
I thought we were doing 10,000.
Oh yeah, it was. What the heck? I think I just copied this by accident. Okay. Well, we'll have to adjust a little bit.
I was a little confused because I heard the 3,000. I was like, I thought it was 10,000.
No, I just keep looking at this question up here. I need to put a barrier there or something. Come on, man. Okay. That's an easy fix though. Everything's the same, just change that to 10. Okay, so this guy $10,404. So that was the first, no, that was B. Now, if we do 1 and 1, it's gonna be 10,400. The last one, redo it to 4. That'd be 10,406.04. Any questions on these first two examples?
And what was the monthly one?
Monthly, be part B. What to do on the next page. So just change the 4 to 12. Would be 10,407.42.
I guess 408.
Yeah, depending if they want 42 cents. So as you can see, compounding does have some effect, but it's not a huge effect since it's just 1 year. Okay. All right, so example 3. That's weird. It looks like they're going to get into compounding continuously. Yeah, so as soon as you see this keyword here, continuous, we're going to use a different formula. It will not be the other one that we just did. Okay, so to make us practice using the E function, E is a number. So let's start there. Let me give you the new formula and deal with the little numbers there. So e to the 4.3. E is just a number, just like pi. It's a special number. It's nothing crazy. So all you got to do is use the E button. 3b is 2e to the 4, 3. So here, all you have to do is use the E button, which is on all scientific calculators. Second ln on this one. Just do 4.3. That's all you got to do. So E is about 2.17 or something like that. It's just a number. So 73.7, I guess. 2 times second ln 3. So they just want us to do those so you know that the formula is going to be using an E, and E is just a number. So don't let that bother you. So this is the continuous compounding formula. So A is equal to E, sorry, P times E to the RT. So PERT. P is still principal. R is rate. T is still time in years. Okay. Still the same. Example 4 says if you invest 3,000, so P is 3,000. R is 5%, which is 0.05. Compounded continuously, so that tells us use the PERT thing. Time is 12. So future amount will be 3,000 times E to the 0.05 times 12. Okay. So 3,000 E to the 0.05 times 12. That's all you gotta do. So it's about 5, 4, 6, 6, and 36 cents. So round to nearest cent unless they tell you otherwise. Any questions on number 4? Right, we're just getting it from, all this info came from here.
For the formula, it'd be 5,000 E. And then the rate is, the first account says quarterly, so it'd be,
Yeah, so you have two formulas at once. You gotta compare them.
oh, compare, oh. So that'd be 0.08
Mhm.
by 4. And then the second formula would be 7, that'd be 0.792, right?
Yeah, I think you're right. Let's see.
And then it's times E.
The 8% is the compound, right? Yeah. So that one is N is 4, and then the other one is with the E. Yeah.
Oh,
Let me write down everything. Okay. So let's go ahead and do that one. So we have one account that is not continuous. So this is a continuous one. And this is the quarterly compound. So let's call this count one and count two, so we don't get all mixed up here. So for number 1, A is equal to 5,000 times 1 plus 0.08 over 4 to the 4 times 6. Account 2 will be 5,000 times, well, I can just put the E there, I guess. Times e to the 0.0792 times 6. So let's see which one is the better investment, right? One has a slightly higher rate, but it's only compounded 4 times a year. The other one has a lower rate, but it's continuously compounded. Let's see who wins here. It's the same amount of time, 6 years. Oops. So 8,042, okay. 8,042 and 19 cents. Now let's do the E, 5,000. 0.0792 times 6. Okay, so it looks like the other one was better. At least in this amount of time. If I would have been longer than 6 years, the continuous would probably win out. You see how it's pretty damn close in 6 years, right? But let's say this was 20 years, I probably would have picked this. Because compounding continuously over 20 years is a lot more money than just quarters. Credit cards are usually continuous. All right. Do you have any questions on this? Okay, let's see. Let's move on to something else, I guess. Annuities. Give me a second. Yeah, I think we should use this example. I don't have the annuities formulas memorized, not gonna lie to you. I had the rest memorized, but these are a little more complex, as you can see. So let's write these down real quick and see how far we can get in the last few minutes. At 30 minutes, I think 20. Yeah, should be good. Yeah, I guess so. You guys cool on this page? Right, start something new then. Go into annuities.
Is there a final?
Yeah, no, there's. I think, well, let's look at our schedule real quick. We're slightly behind schedule, not too much. I forgot to factor in spring break in this calendar. But oh, well, who cares? So we did simple and compound right here. We're gonna start this today, 7 to 5. Technically, you should have already done exam 2, but it should still be open. There's a couple of quizzes in there as well. I would do the review that we talked about. I think I posted that a while back for test 2. So if you guys haven't done it, please do it soon. I think I sent you which sections it was about, right? It's been a little while ago, so I forget. But we are here. Okay. Next week, we're probably gonna hit this a little hard to catch up, but notice we got test 3 right after that. So I'll probably, if not next week, the week after, we'll be reviewing for test 3. And then we're gonna go into statistics type stuff. And that'll be the last thing we talk about. Test 4 is mainly about counting and stats, like some like intro stats type stuff.
I did statistics in high school, so I
Nice.
remember a lot of stuff.
Okay, yeah, so this shouldn't be too bad. All right, so that's where we're headed. So we have one test 4 right before the final, and then that's it. There's a couple of sections at the end about voting methods and flaws of voting methods, which see how, if we have time for it, we'll see how that goes. But for 7.5, let's look at the homework problems, just so we can, you have examples that look exactly like homework, because 7.5 is a little more in depth. So I'm going to write down this formula here, and then we're going to start this question. So 7.5 is annuities. Okay, so in this question, they said find the appropriate formula to find the value of the annuity, since there is a periodic deposit. So basically, at the end of every month, they're putting in $30. It's compounded monthly for 40 years. So what is once the annuity matures, right? In 40 years, how much money are you gonna have? That's what A is gonna be. Okay. So usually annuities are stuff like mortgages or investment accounts, certain types of bonds, that type of stuff. But
I know the military bonds like that too.
yeah, for sure. But for sure, mortgages are similar to this because you're putting in monthly payments to like a house. That is an annuity, a type of annuity, which we'll talk about, I think. Maybe this section or the next one, I forget. But let's write this formula down because we're going to need it. So this time P is now payments. It's not principal. So P times, I'm going to try to make this a little prettier. Let's see if I flip that fraction over here. Use this. So when it comes to punching in your machine or whatever, it'll be easier to calculate. N times P over R times okay, times one plus R over N to the NT. I'll show the screen in just a second. One, because nobody can see it yet. Sorry. Here. So I'm modifying the one that's in the homework because this is easier to plug into your calculator, and I think it looks a little prettier. Maybe you disagree, but my recommendation is use this one. So you can calculate this part first, and then calculate this second if you want, or you can try to do it all at once. Up to you. Just make sure this -1 is not inside these parentheses, right? It's outside by itself within the bigger parentheses. So be careful. Okay, so example 1, I'm gonna do that one right there in the homework. Okay, so let's see, let's look at the example. Let's not reveal too much, make it a little hard for us. So it says, use the appropriate formula, find the interest. Okay. So it wants to find, I'm sorry, use the pro forma to find the value of the annuity, which means they want the future amount that you're gonna have. So if you put away 30 bucks every month at 5% for 40 years, how much are we gonna have? Right. And then part B is gonna say, what is the interest that you made on those 30 bucks every month? So there's three things we kind of have to do here. But let's write down P. So I'm depositing 30 bucks every month. So P is equal to 30. I'm gonna write that down. $30. Rate R is 0.05, right? That's percentage. My time is 40. Now, what is N?
Then would be the time,
So T is time.
or no, N is the number of times in.
Yeah, a number of times we compound, right? So we're compounding in 1 year. It says compounded monthly, the rate. So N is 12. Okay, so let's plug all this guy in into your formula, and you'll have your future amount. I like these kinds of questions because it makes you want to save your money a little bit. Like, oh man, I should put more money away. Okay. So using this guy here, this formula. So 12 times 30 over 0.05 times 1 plus 0.05 over 12 to the NT, which will be 12 times 40 minus 1. Okay. So what is this nonsense going to be? Let's see if we get it right or not. So the fraction bundle will make it a little nicer. I would stick to math print for these. Since it's in a fraction like this, it's understood it's separate. So I don't really have to put parentheses, but you can. I want to put it on the next one because there is no fraction here. 1 plus, well, actually, we should put 2 sets. 1 plus a fraction of 0.05 divided by 12 divided by raised to 12 times 40. And then outside that whole thing, you do minus 1 and close the parentheses. So it looks like 45,780. That sounds reasonable. Let's see. See, that's what they got. Right now that we have an actual homework problem, we can check their stuff. So they got the rate, you got the N, same thing we did. 45,000. They rounded to, they said right here, the nearest whole number. So nearest dollar. So they don't care about the change in this homework, at least this question. 45,781. So that was how much we made in 40 years of just putting $30 away. It's not too shabby, right? So the question, this is part A, right? Part A. Part B says, what is the interest you made, right? The interest earned. Because I'm pretty sure that this is a lot, there's somewhat more than just $30 a month, right? You made money on the interest. So how would you figure out how much of that is interest? I already did the hard part. The second part, if you just think of it logically, it's not too bad. Like, in other words, how much money did you put in? For how many years?
For 40, so
So how many payments is that?
that's 12, so
Right. Total money you deposit in 40 years is going to be, you said $30, 12 months in a year, 40 times, right? So this is the actual money I gave away. I deposited or whatever. So the money that my actual money that went in there is only 14,400. But thanks to all that interest, I made quite a bit, right?
Yeah.
So how much did I make in interest?
so we just simply subtract 45,700 that you went from the 14.
Yeah. Exactly. Yeah, that's true. So now we know how much we made. That makes sense. So we made $31,000 and 381 in 40 years by just putting away $30. So they tell us, that's what they say, start retirement accounts as early as you can because the time variable has the biggest impact. So if you're at 18, putting a little bit away has a bigger impact than putting more money away at an older age. Sooner the better, sooner the better. Okay. And yeah, that's all you do here. So they subtracted it, found the interest, and that's what number one is going to be about. Okay. So just find the total and then find the interest. Any questions on number one here?
No.
Question two, similar. Let's see if it's worth doing. Try and do something more different. It's similar, same thing. This one's different. This one says, let's look at the example so we don't do the same one. They want to know how much money I should put away. So this is a question that we ask ourselves all the time, like, okay, if I want to save X amount of money, let's say I want to save 100 grand in 10 years from my future house, how much do I deposit every month given a certain interest rate, right? Those are questions that are important and that we want to know. Or what things we should do is create like a sinking fund, put money in there, and then eventually use that to buy a car cash. Like you don't get a loan, you create a savings account, put money in there until it's time to buy it. That's what we're supposed to do, but of course, that's not always reality. But these questions can be answered, like how much money do I put away to buy the car I want? What is the rate that I need, et cetera, et cetera. This is the form you're gonna need if you're putting money into an annuity type of an investment. So let me see if I can make this a little prettier. We could put a -1 on that bottom piece. That way we don't have to worry about having so many fractions in a fraction. So this is what I'm thinking of. P being the payment. I'll show you in just a moment. This would be A times R over N times the bottom garbage. 1 plus R over N to the NT minus 1 to the negative 1. So this is the formula that I slightly adjusted. So it's nicer, prettier. If you like the other one, that's fine. I don't care. I don't care how you do these problems, just show your work and use legit math, you'll be fine. I recommend you use this one to solve for payment. So P is payment. So the question for an example 2 is going to be, how much do I put away, right? No, wait a second.
So what would the negative one be? That's outside the.
Negative 1, that just allows me to write it on top instead of on the bottom like it had on the formula. So
Oh.
basically that represents 1 over. Okay, so negative powers make it turn into a reciprocal. Okay, let me switch over so we can write down the information. All right, so they want to know P, the payment. They said that the rate R is 0.07. Compounded annually. So I'm only compounding once a year. N is 1. Time is 16. Financial goal is 130,000. So they want to save up to 130K in 16 years at a 7% rate. How do I do that? So that means that A is 130K. Okay. So we got everything we want. R, N, T. Find out the payment you got to put in and see. So 130,000 times 0.07 over 1 times 1 plus 0.07 over 1 to the 1 times 16 minus 1 to the negative 1. So punching this into your calculator should give us how much you need to put away every month to hit that goal. So 130,000 times 0.07. I'm not going to put the 1 because it doesn't really do anything. Double parentheses because I got to make this piece first. So 1 plus 0.07. That 1 doesn't do anything, so who cares? To the 16 minus 1 second parentheses. Okay, that doesn't sound right. Let me look at this again. Oh, forgot the negative 1. I'm like, how the heck am I going to put away more money than what I... That's silly. Okay, so if I want to have this money in 16 years, compounding only once a year, I gotta put away 4,661 per year or per month, sorry. Which is a lot. Let's see what they got. So there's ARN. So that was all correct. Calculate your P, 4,662. So they round to the nearest dollar. So put away 4,662 and 50 cents. Oh, I'm sorry. Just two. Okay. As you can see, if you have money, you can make more money. If you have no money, then it's difficult. That's I think one of the big issues. And how can you put away money if you're barely making it paycheck to paycheck, right? So a lot of people don't have that kind of extra cash.
I mean, I'm doing okay for now, but I decided to get 2 jobs and my mom's like, why? And I was like, I'm young.
Yeah, this is the time to put money away and invest and buy a house and stuff.
Not only that, when I like hit my 30s, like I'm gonna be slowing down then 40s. And like I was like, Mom, you take care of yourself real well, but when you're in your 60s, you know, like I'm gonna have to start making sure you're okay and take care of you and help you.
True.
And she was like, no, because I can take care of myself. I'm like, I'm saying this, you know, like medical wise, like needing a surgery or something. I'm not always gonna be able to work.
Yeah, I guess she's in denial. Like, they're not going to be decrepit. I will stop here. I don't think we have time for another one. So try your best to catch up to this point and try out some of the annuity questions, and then we'll go more in depth into annuity because they're kind of interesting.
I've been doing a lot of the paperwork on the paper rather